Hi guys, I'm Anika and this is 8th grade science with Allstem. This video is part 2 of the matter, properties, and change standard. If you haven't watched part 1 yet, it's linked down in the description box. This video covers physical changes, chemical changes, and the conservation of mass. As always, all of our questions are timestamped, so if you want to skip an explanation for any of the questions, just go on ahead to the next timestamp. If you want to review certain topics after this video, we have a links for further reference page in the description box along with all of the questions in this video. On this page, there's a link that goes with each question, so you can work on the challenging ones. All that being said, let's get started with the first question. Question 1. Identify the following as physical or chemical properties of matter: shape, reactivity, odor, color, pH, density, flammability, solubility, melting point, boiling point, and conductivity. You can pause the video here and take time to answer the question and then play it again when you're ready to see the answer. So the answer to this question is the physical properties are shape, odor, color, density, solubility, melting point, boiling point, and conductivity. And the chemical properties were reactivity, pH, and flammability. So if you got that right, go ahead and skip to the timestamp of the next question. Otherwise, let's go through and figure out what determines a physical or chemical property of matter. So first, let's look at the physical properties in this question. A physical property is a property of matter that we can observe without making any changes to the matter's chemical composition. Shape is a physical property because we can observe it just by sight or just by looking at the substance. Odor is a physical property because we can observe it just by smelling the substance. Color is a physical property because, just like shape, we can observe it just by looking at the substance. Density, which is the amount of mass per unit volume of a substance, is a physical property because we can observe it just by weighing the object to find its mass and measuring it to find its volume. Solubility, which is how easily a substance dissolves in another substance, is a physical property because what we're doing when we're dissolving one substance in another substance is creating a mixture, which is a physical combination of substances. Neither of the substances are being chemically altered. Melting point, which is how hot you have to make a solid for it to melt, is a physical property because we are testing for a phase change. Phase changes are physical changes. They don't change the chemical composition of the matter. For example, if you freeze water to make ice, which is a phase change, the ice is still really just cold water. So melting point is only testing for a phase change. So that's still a physical property. Boiling point, which is how hot you have to make a liquid for it to become a gas, is also a phase change, so it's a physical property. Conductivity, which is how easily electricity or heat travels through a substance, is a physical property because running heat or electricity through a substance doesn't make it a different substance. If I heat up a piece of metal, it's still metal. Now let's look at the chemical properties in this question. Chemical properties are the properties that are observed when the chemical composition of matter changes irreversibly and a new substance is created. These properties usually indicate how substances react with other matter. So, first is reactivity, which is how easily a substance undergoes a chemical reaction. This is a chemical property because to observe reactivity, substances must undergo chemical reactions, which changes their composition. Next is flammability, which is how easily a substance catches fire. When something burns, it is no longer the same substance. It's been chemically changed, which is what makes flammability a chemical property. Last is pH, which is a measure of how acidic something is. To observe pH, the substance must react with a pH indicator. The big thing for chemical properties is that you can't just observe them if you were handed a sample of the substance and nothing else. You need the substance to react with other substances to observe these properties. The substance needs its chemical composition to change, aka forming a new substance. Whereas with physical properties, they don't need to react with other substances. You can be handed a sample of just the substance, and you'll be able to figure out its physical properties. Question 2. Identify the following as indicators of either physical changes or chemical changes to matter: change in color, change in temperature, change in size or shape, production of an odor, production of light, phase change, formation of a precipitate, and formation of a gas. Go ahead and pause the video and play it again when you have an answer. So the answer to this question is the indicators of physical changes are changes in shape and size and phase changes, whereas the indicators of chemical changes are a change in color, a change in temperature, production of an odor, production of light, formation of a precipitate, or formation of a gas. So first let's take a look at the indicators of physical changes in this question. So a physical change is when the form of the matter is altered, but not its chemical composition. So, a change in size or shape is a physical change because when an object's size or shape changes, its atoms/molecules are not being affected. For example, if you chop wood, the pieces of wood have the exact same molecules as each other and the original piece of wood. The same goes for a change in the state of matter. When a substance changes between being a solid, liquid, or gas, all that happens to it is that it either heats up or cools down, aka the atoms or molecules either gain or lose energy. The actual chemical composition of the substance doesn't change. Many physical changes are reversible given the right amount of energy. For example, if you dent metal, given a lot of heat, the metal can be molded back into its original shape. Physical changes do not create a new substance. They merely change the form that the matter is in at the moment. Now let's take a look at the indicators of chemical changes. So, a chemical change is an irreversible change of the matter's chemical composition that creates a new substance. So, the most important thing to note here is the new substance. Chemical changes make new substances. So, first is a color change. Color changes are not sure signs of chemical changes, but many chemical reactions also bring about a color change in the original substance. A new color can indicate the presence of a new substance. Next is temperature changes. Sometimes chemical reactions either take in or release heat, therefore changing the temperature of the original substance. This isn't a sure sign of a chemical change, but physically combining substances doesn't produce heat, whereas chemically combining them might produce heat. Next is precipitates. Sometimes two solutions are combined and they'll combine to form a solid substance known as a precipitate. This one is more obvious because the new solid is a new substance. Next is formation of a gas. This one we see from the simple baking soda and vinegar reaction. When you combine baking soda and vinegar, carbon dioxide is produced. Carbon dioxide is a new substance in that reaction. So it's a chemical change because the gas is a new substance rather than just an evaporated form of the original. Production of an odor is usually an indicator of a chemical change because when a new substance is formed, it can have a new smell. Production of light is also an indicator of a chemical change because if two substances combine and the reaction excites the electrons within the substances, they might release that energy in the form of light. This is actually how glow sticks work, by combining two liquids which react to produce light. The light production shows that the substances aren't just combining physically, but actually exchanging electrons in a chemical reaction. Question 3. Which of the following colors would bleach, a very strong base, show on a universal pH indicator? A. Red, B. Purple, C. Green, D. Yellow. The answer to this question is B. Purple. So to figure out how we answer this question, the first thing we need to do is take a look at a pH scale. So this is a pH scale. What a pH scale does is tell us what color would come up for each pH value on a pH indicator. So if you put a pH indicator into something with a pH value of 1, for example, you would get this dark orange color. So the pH scale ranges from 0 to 14. Values from 0 to 6 are acids. And acids on a pH scale are typically associated with warmer colors such as red, orange, and yellow. Value 7 is for neutral, and neutral is always green. Values from 8 to 14 are for alkaline substances. Alkaline substances just mean bases. And values from 8 to 14 are typically associated with cooler colors, such as blue and purple. Red is the strongest acid, and purple is the strongest base. Therefore, bleach, which is a very strong base, would show purple. Question 4. What is the universal solvent? The answer to this question is water. So the first thing we need to do here is we need to know two terms, solute and solvent. So when one substance is dissolving in another substance, such as salt dissolving in water, the substance that is being dissolved is called the solute. So when salt is dissolving in water, it is the substance being dissolved. So in that situation, salt is the solute. But this question is asking about the solvent. So the solvent is the substance that is taking in the solute. So the water is taking in the salt. Water is known as the universal solvent because so many things can dissolve in it. Question 5. You find an unidentified substance in the lab. You perform some tests on it and compare it to other known substances. Based on the table below, what is the unidentified substance? You might need to pause the video on this screen so you can take a longer look at the table. So the answer to this question is baking powder. If you got that right, go ahead and skip to the next question. Otherwise, let's take a look at this table and compare the properties of the unidentified substance to the other substances given. So the first property given here is color. However, all the powders are white, so this doesn't help. This shows that color isn't always the best indicator when it comes to classifying substances, and you should try not to rely on it. The next one given here is texture, also known as shape, which we listed as a physical property. This is also not too helpful because two of the powders, baking powder and powdered sugar, have the same texture as your unidentified substance. However, we can cancel out cornstarch because it has a different texture than your substance. But physical properties can often be applied to more than one substance, as shown here. The last one is a chemical reaction from the substances with iodine. Here's where that you can find your substance's baking powder, because only baking powder has the same chemical reaction to iodine as the unidentified substance. Cornstarch did also turn purple, but we canceled that out when it came to texture. And powdered sugar has a very different reaction to iodine than the unidentified substance does. So, because the properties of the unidentified substance match the properties of baking powder, we know that it is baking powder. Question 6. Which of the following reactions, assuming that they are all in a closed system, is impossible? A. 2H2 plus O2 results in 2H2O. B. SO3 plus H2O results in H2SO4. C. N2 plus 3H2 results in 2NH3. D. NH3 plus HCl results in N2H6Cl. You might need to pause the video and take more time on this question. So the answer to this question is D. NH3 plus HCl results in N2H6Cl. So if you got that right, go ahead and skip to the next question. Otherwise, let's take a look first at some of the terms needed to solve this question, and then how we get the answer. So when looking at a chemical equation, there are some things we need to know. So things on the left side, the ones being added to form this product over here, these are known as the reactants. These are the substances that undergo the chemical reaction. And now the thing on the right side, as you may have heard me mention a second ago, is the product. This is the substance formed through the chemical reaction. It's created from rearranging the atoms and bonds in the reactants. This number here, so an example, this 2 in 2H2 is a coefficient. So this is a number before a chemical formula. So the chemical formula here is H2 that shows how many of its molecules are present. So 2H2 says that there are 2 H2 molecules. And then this little number, we're going to go with H2 again. This is known as a subscript. And a subscript, or the small number to the right of different chemical symbols, shows how many atoms of each element there are per molecule. So in 2H2, hydrogen, which is the H here, has a subscript of 2, meaning that there are 2 hydrogen atoms in every H2 molecule. So because there are 2 of these H2 molecules, this compound over here contributes 4 hydrogen atoms in total. So those are the parts of the chemical equation themselves. And then these are some other terms you need to know for this question. So the law of conservation of mass is a law that states that matter is neither created nor destroyed in chemical reactions. So in a closed system, a chemical equation with 4 hydrogen atoms in its reactants will also have 4 hydrogen atoms in its products. It also means that the total number of atoms in the reactants will be equal to the number of atoms in the product. A balanced equation is when the mass and charge of the reactants of an equation are the same as for the product. This goes with the law of conservation of mass. And lastly, a closed system is a system that does not allow the transfer of matter in or out of the system. In this question, the statement that it's a closed system means that the equations must follow the law of the conservation of mass, because no matter can escape or enter the equation. So in this question, the number of atoms of each element have to be the same in the reactants and the product. So now let's take a look at the equations in the multiple choice and see which one does not fulfill the law of conservation of mass. So what we're going to do is for each equation, we're going to count the number of atoms of each element in the reactants and in the products. So in the first equation, in the reactants, we have 4 hydrogen and 2 oxygen. And in the products, we have 4 hydrogen and 2 oxygen. So this equation does meet the law because both sides have the same number of atoms of each element. So let's do the same with the next equation. So we have 1 sulfur, 4 oxygen, make sure to count this one in the H2O, and 2 hydrogen. And in the products, we have 2 hydrogen, 1 sulfur, and 4 oxygen. So this one also meets the conservation of mass. Let's take a look at the next one. In the reactants, we have 2 nitrogen and 6 hydrogen. And in the products, we have 2 nitrogen and 6 hydrogen. So now by process of elimination, we know the answer is D, but let's go ahead and count it anyways. So in the reactants, we have 1 nitrogen, 4 hydrogen, again, make sure to count this singular hydrogen over here, and 1 chlorine. And in the products, we have 2 nitrogen, 6 hydrogen, and 1 chlorine. So these are not equal. So this equation, answer D, does not meet the law of conservation of mass. Question 7. Balance the following chemical equation. Blank C3H8 plus blank O2 results in blank CO2 plus blank H2O. So the answer to this question is 1 C3H8 plus 5 O2 results in 3 CO2 plus 4 H2O. So if you got that right, go ahead and skip to the next timestamp. Otherwise, let's talk about how we balance this equation. So what are we trying to do when we're balancing a chemical equation? We're trying to find the coefficients, which is what these blanks stand for each of these compounds that'll make the element numbers, or the number of atoms of each element, Same in both the reactants and the products. So we're making the equation follow the law of conservation of mass. So the first thing we're going to do is count the number of atoms of each element we have on both sides of the equation. So in the reactants and in the products. This is especially helpful if you're just starting out with balancing chemical equations. As you get more familiar with the process, you may not have to do this step at all. So in the reactants, we have 3 carbon, 8 hydrogen, and 2 oxygen. And in the products, we have 1 carbon, 2 hydrogen, and 3 oxygen. So now we're going to take the most complex compound in the equation, and that in this equation is C3H8. We want to pick any element from this compound that only has one occurrence on the other side, or only shows up in one compound on the other side. So the options in this compound are carbon and hydrogen. Luckily, both carbon and hydrogen only show up in one compound each on the other side. So I'm just going to pick hydrogen for this example, but you can also start with carbon. So we know that there are 8 hydrogen in the compound we picked, but on the other side there are only 2 right now. So we're going to add a coefficient of 4 to make both sides equal. We also put a coefficient of 1 in front of the C3H8 because we're doing trial and error and assuming that there's only one molecule of this compound. We won't need this coefficient in the final answer because normally when there's only one of the molecules, we don't put any coefficient. For right now, we keep it in for math purposes. Now we repeat the step we just did with another element. I'm going to use carbon because it's the other element in the original compound we picked. So right now, the left side, or the reactants, have 3 carbon, and the right side only has 1. So we're going to add a coefficient of 3 here. The last element in this equation is oxygen. So there's already some coefficients for the oxygen over here. Here we have 6 oxygen atoms, and here we have 4 oxygen atoms. So that's a total of 10, whereas the reactants only have 2. So to fix that, we add a coefficient of 5 to the oxygen molecule. If we check now, we should get the same number of atoms of each element on both sides. We have 3 carbon on both sides, 8 hydrogen on both sides, and 10 oxygen on both sides. Question 8. Balance this chemical equation. Blank Al2O3 results in blank Al plus blank O2. Okay, so the answer to this question is 2Al2O3 results in 4Al plus 3O2. So we're going to go through the same steps we did with the last question. So the first thing we did in the last question was count the number of atoms of each element we have in the reactants and in the products. So in the reactants, we currently have 2 aluminum and 3 oxygen. And in the products, we have 1 aluminum and 2 oxygen. So let's start again with the most complex compound in the equation and pick an element from the compound. So I'm going to start with aluminum because Al2O3 is the most complex compound in this equation. So currently there are 2 atoms of aluminum in the reactants, but only 1 in the products. So to fix that, we're going to add a coefficient of 2 to the aluminum in the products. Again, because we're doing trial and error and assuming that there's only one molecule of this compound on the left, we need to put a coefficient of 1 for right now. So now we need to match up the other element, oxygen. So if we have one Al2O3 molecule, that means there's 3 oxygen molecules in the reactants. When you look at the other side, however, the oxygen only comes in the form of O2 molecules. You can't get 3 oxygen atoms from molecules that come with 2 oxygen each. So we have to try something different. So now let's try starting with the oxygen. So currently there is a compound with O3 molecules on the left and O2 molecules on the right. So the smallest possible number of oxygen atoms that'll work with both sides is 6 because it's the first number we can get from both O3 and O2 molecules. So here we'll put a coefficient of 2 because 2 times O3 will get us 6 oxygen. And here we'll put a coefficient of 3 because 3 times O2 will also get us 6 oxygen. So now we need to match up the aluminum. If we have 2Al2, we have 4 aluminum atoms in the reactants, and we need 4 in the product. So let's give this aluminum atom over here a coefficient of 4. Now if you check this, you'll get 4 aluminum on the left side and 4 aluminum on the right side, and 6 oxygen on the left side and 6 oxygen on the right side. The big thing to notice with this question is that it didn't work the first time. Balancing chemical equations is trial and error, so the first try isn't always correct. Hopefully those questions helped you review these substandards. Like I mentioned earlier, check out the links for further reference page for extra practice with these topics. If this video helped you out, please like, share, and subscribe. Thanks, and I hope to see you in the next video.